Okay, so Pawan, I have started recording this our session of mock interview for ISRO. So I'm going to take your mock for ISRO on the similar line of ISRO, right? So my question to you is first
Okay, sir.
about your introduction only. Please start your introduction, Pawan.
Sir, I am Karthik Durgapan. I am from Prakasam district, Andhra Pradesh. My father is a farmer and my mother is homemaker, and I have one sister. I completed my 10th class from my native place only, and I completed my 12th class from Sri Pratibha Junior College, Ongol. And after that, I studied my BTech in mechanical engineering from NIT Raipur. After completion of my BTech, I joined L&T and I did 2 years job over there. And now currently I am pursuing my masters from IIT Hyderabad in mechanics and design streams.
Okay, so mechanics and design, huh? Okay.
Yes, sir.
Okay, so Pawan, tell me, like you are doing your MTech from IIT Hyderabad, Mechanics and Design, and I'm very sure you are going to get jobs from
Yes.
there. So you are going to get jobs from there also. You have worked in L&T also for 2 years. So
Yes.
so
Yes, sir.
I'm not getting why you want ISRO.
Sir, I am more inclined towards research oriented types of jobs. And it's my ISRO getting job in ISRO is like my childhood dream. When it was started in my 7th class only. The first time when I presented a model of a small rocket which
Hmm.
runs by water and air mixture
Hmm.
in the science fair. From that day only, like it was like my dream to get into ISRO, and
Hmm.
it's the best. I think it will be the best place for me to prove myself, sir.
Okay, so do you think you have that temperament, research orientation, research temperament? Do you have that, which is required
Yes,
in
sir.
scientist?
Yes, sir.
How do you know that?
Uh, Sir, sir, I am doing job in L&T, but I found that it was like the job was not that much research oriented. So I think I need to go for research. That's why I taken even MTech also, sir.
Okay, can you name three big scientists associated with ISRO?
Okay, Vikram Sarabhai, a founder, and Satish Dhawan, with his name only, center's name was, and Abdul Kalam.
Okay, so you could get it, huh? So
Yes, sir.
how Abdul Kalam was associated with ISRO?
Sir, he is associated with both DRDO and ISRO. He is the
Have you read his
mo-
book, Wings of Fire? Wings on Fire?
no, sir.
You're not studied. So you know he was associated with SLV. You know what is
Okay.
SLV?
Satellite launch vehicle, sir.
Okay, and then after SLV, what came?
Next version is ASLV, and
And
then
then
PSLV and GSLV, sir.
okay. So what is the difference between PSLV and GSLV?
Sir, I just know the abbreviation only. PSLV means Polar Satellite Launching Vehicle, and GSLV is Geosynchronous Satellite Launch Vehicle. But
So why
I
why it
don't
is
know that.
called polar satellite? Why it is called polar satellite?
Sir, I think the difference is in the orbit, in the orbit on which it launches the satellites, sir. Geosynchronous orbit
No,
and
what is the
polar
meaning of pole?
orbit.
What is the meaning of pole?
Sir, pole, the end points,
No.
we call south pole, end points of the planet.
Earth has north pole, south pole. You don't know that? Earth has.
Yes, yes, sir. That's why
So
I'm saying,
okay. So why this polar? Why it is called polar then? Is there any satellite which moves from pole to pole?
maybe from maybe, sir, from one pole to another pole. The satellite which moves from one pole to other pole was launched by PSLV. Maybe I'm guessing.
Okay, you know ISRO launches the satellites in the some particular series name, in the name of some series. Can you tell me that name of series in which ISRO launches the satellites?
Sir, like a recent launch was PSLV C51 and the previous was PSLV C50.
There's Indian remote sensing satellites. There are communication satellites, INSAT. Any idea about a remote sensing satellite or communication satellites?
No, sir.
Okay, as mechanical engineer, can you prove me the height of geosynchronous satellites, geostationary satellites? At what height they are launched?
Geostationary. I guess it was somewhere around 400 kilometers from the Earth, sir.
Geostationary. Are you sure?
Uh,
Geostationary is 36,000 kilometers, Pavan.
okay, sir.
36,000 kilometers above our surface. And this is derived, when orbital velocity. You know what is orbital velocity?
Yes, sir. Orbit, the velocity with which, if we throw an object from Earth's surface, so that it can reach its orbit.
What is that value?
Sir,
Escape
I
velocity,
remember.
orbital velocity?
Yes, sir. Escape velocity, I know it was somewhere around 11.3 kilometer per second, sir. But
Okay. So
orbital velocity, I didn't remember the value, sir.
so suppose I throw this pen with 11.2 kilometers per second. That is per second or per kilometer or per hour? What is
kilometer per second, sir.
Okay, so if I throw this 11.2 kilometers per second, what will happen to this pen? Suppose I throw towards you.
No, sir. Towards me means it will reach to some point, but if we throw upwards, then it won't come again, sir.
Okay, I give you, there is an electron gun. There's an electron gun. I keep it horizontal and fire electron at 12 kilometers per second. What will happen?
Sir, electrons means they are like their mass is very, very less, sir. It may get deflected towards where the positive charge is.
There is no positive charge, neutral field. When a neutral field, I kept a gun, electron, neutral field, and I fire electron at 12 kilometers per second horizontally from the height of my body. Now what will happen? And this velocity is more than escape velocity.
Maybe if it is buoyancy, maybe because of buoyancy forces, if it changes its direction, then maybe it
What is
may
orbital
go up,
velocity?
sir.
What is the value of orbital velocity?
Orbital velocity, maybe it's less than escape velocity, sir, but I don't know its value.
Okay, what are your favorite subjects, Pawan?
Sir, strength of materials, fluid mechanics, thermodynamics.
Okay, so strength of material, which part you are comfortable? So you have done 2 years job in L&T.
Yes, sir.
Did you do any work profile there related to designing?
No, sir. It was a construction project, sir. Pipeline construction I worked in.
Which material were you using in pipeline? The pipes
Sir,
were made up of.
It's a carbon steel, a X70 grade carbon steel, PSL2 pipe. With its carbon percentage is percentage 0.12, it will come under low carbon steel category.
But I have heard that these pipes are made up of CI steel, CI cast iron. No,
sir. CI
pipes.
DI.
They are CI
Yes, sir.
pipes.
Yes, sir. CI DI, many types of pipes. That depends on application. And I worked in pipeline construction, but it was oil pipeline, sir. Product pipeline.
Means
like petrol or diesel, it will that will flow, not
so
water or something.
So for what product you were designing these pipes?
Typically petrol or diesel, sir. It will connect from refinery in Paradip to Hyderabad. And in between there are 2 more marketing terminals at Vijayawada and Berhampur. and Rajahmundry marketing, three, four marketing terminals are there. For
GAIL is working in
island
that
gas
direction.
industry,
Gas
what sir?
Authority of India Limited is also working in that.
Gas authority, they are also having pipelines, but we don't have any relation with them. It's only completely owned by IOCL only.
So you are providing to IOCL these pipes.
No, sir. We are not providing. Actually, L&T's job is only construction, and IOCL only purchases the pipes, and it will issue to L&T. Only our job is to construct the pipeline, lay the pipeline.
Okay, suppose I want to do modeling analysis of this pipeline.
Okay.
How shall you do that? I want to know how much is the pump work required for me to pump oil for thousands of kilometers in this pipe.
Yes, sir.
How shall you do that? How shall you approach that?
Sir, in this case, we have to find out the friction factor between the fluid and the pipe material, and from that we can calculate the head loss using a Darcy friction formula, FLV square by 2GD, and then we can calculate rho g QHL power loss. Based on that power loss, we can know the pump work.
No, I'm asking you to model. I'm not asking you to calculate the pumping power only or power loss. I'm saying how to model it. You know what is modeling analysis?
Means modeling means we need to simulate the lab. For that, sir, main and the Reynolds number, we have to take care of that Reynolds number of model, and actual prototype should be same.
So why you are considering only Reynolds number? Why not other number?
Sir, it's a internal flow, and it is the it is only governing the flow, no, whether it is laminar or turbulent.
So in Reynolds number, which is used for fully submerged flow, you know there is something which is called fully submerged flow. Is it an example of fully submerged flow?
Like only one side is completely wetted, sir. Only internal and not completely submerged.
So
yes,
this
sir.
is
Reynolds
not
number can be Reynolds number can be used for
can
other
I call
submerged.
Can I call this case fully submerged flow?
Fully, no, sir. It's a internal flow through pipe only.
How do you define fully submerged flow?
Sir, fully submerged, it's like a submarines or something, which was not which was completely surrounded by fluid or water.
Okay, so pipe designing के लिए, pipe modeling के लिए you use a Reynolds number, right?
Yes, sir.
What are the forces involved in that Reynolds number analysis?
Sir, viscous forces, inertia forces.
What is the meaning of inertia forces?
Sir, inertia forces are like due to the acceleration of the fluid.
So can you tell me what is the Newton's second law and explain me where is the inertia force in there?
Sir, Newton's second law is for a solid body, we can tell it as a external force, F external equal to d by dt of momentum. And in this case, sir, summation of viscous forces plus pressure forces plus gravity forces is equal to F external in this pipe flow case.
Okay. So where is the inertia force in that? Newton's second law.
External force is the inertia force.
The force which I am applying, huh? Okay. Now this is the pen. I applied force on this, and it is accelerated. Okay. It is accelerated. Tell me, sir, where is the inertia force here?
Sir, whatever the force you are applying is inertia force, and as per D'Alembert's principle, we take it in the direction opposite to the acceleration to write the static equilibrium equation.
Okay, can I not use Newton's second law for fluids?
Yes, sir, we can.
So as you said, it is only for solids.
No, I just told that for solids we can write it as F equal to dp by dt.
So how
And in
that
this
will be
case,
different? If I use Newton's second law for fluids, how that will be different?
sir, usually that momentum is mass into velocity. Usually for solids mass is constant, but sometimes for mostly for liquids, no, mass is also variable. Mass variable, dm by dt will come. Like d by dt of mv equal to m into dv by dt plus v into dm by dt.
Okay, you have pen and paper with you?
Yes, sir.
Take a body of mass 10 kg
Okay.
and put it on the surface
Okay.
with coefficient of friction 0.1.
Okay.
Now you apply a force of 5 Newton
Okay.
horizontally on this, and in the second case vertically. First
Okay.
you apply 5 Newton horizontally, and second case you apply 5 Newton vertically.
Okay, sir.
Tell me what will be the inertia force in both the cases, and what will be the stress induced in both the cases.
Stress. Okay. Sir, in the first case, if we take acceleration due to gravity as 10 Newton, then the normal reaction is 100, and the friction force is 10 Newton, sir. We are only applying 5 Newton. That means it won't move, sir. Inertia force, there will be inertia force will be there. That will be due to the mass of the body. And no stress will be generated, sir, in this case. And in the second case, the body
What
is
will be
acted upon.
inertia force in first case? No stress, but what is inertia force?
Sir, body is not moving, sir.
Okay. Tell me what is, in Newton's second law, if you talk about
Yes,
Newton's
sir.
second law, what is the net force acting in first case?
Sir, net force 5 Newton only, sir. Because the friction
If
is
there is a net force
yes,
5 Newton, then inertia force, which is ma, that is also 5 Newton. Why body is not moving?
no, sir. The friction force is 5 Newton, and the applied force is 5 Newton. Both are getting cancelled.
So net force is?
Net force is 0, sir.
Okay. And what is the inertia force now?
Sir, inertia force is m into a. Here it's not accelerating, so it is 0, sir.
So inertia force is also 0. Stress is also 0.
Yes, sir.
Okay. And you said friction force is 5 Newton. Why not 10 Newton? You calculated now mu mg.
Yes. It was the maximum friction force, sir. 10 Newton won't applied every time. Like if we apply 6 Newton, then it will the friction force developed will be 6. If it is 7, if it is, then it will be
Why
7.
friction force is increasing? Why it is changing?
Like, sir, if 10 Newton force is always acting, then it will even though if we are applying 5 Newton like this, the body have to move in that opposite
What is
direction.
this? What is this called? Maximum friction force.
Maximum friction force.
What is this name? Limiting friction.
Limiting friction force. Yes.
What is the 5 Newton?
Uh, 5 Newton in this case, like static friction force.
Static friction. What is the third one?
Sir, one more dynamic friction will be there when body is moving.
Dynamic or
like,
kinetic? Kinetic or dynamic?
Kinematic friction, sir.
Okay. What will the value of kinematic friction? More than 10, less than 10?
Sir, if friction coefficient is same, then it will be 10 only.
Okay.
Like yes, sir.
Are you sure it's 10 Newton? So limiting is always equal to kinematic? Yeah, kinetic friction.
Yes, sir.
So as you said, maximum friction is limiting friction, but kinetic friction is also maximum friction.
Sir, kinetic friction means it's the friction force acting when the body is moving. Like if in place of 5 Newton, if it is acted by 15 Newton, then there will be some opposing friction always there. That will be 10 Newton. There may be a case because of the motion, the frictional coefficient may reduce, sir, sometimes. Instead of 0.1, it may be like 0.05 or something. So it is not that every time it is limiting friction only. Because of the motion, the coefficient of friction may change.
Okay, when body starts moving, suddenly friction falls.
Okay.
What is the reason for that?
Sir, like when it is stationary, there will be some it possesses some inertia, sir. But when it is in motion, because of that inertia only, like inertia means stationary body wants to be stationary and moving body wants to be moving only.
Okay, the second situation was vertical force, 5 Newton.
Yes, sir.
Tell me the stress induced and inertia force.
Sir, 5 Newton is there, and at the bottom of the body, 5 Newton reaction will be developed. So it will be in the compressive state of stress, 5 Newton upon the area. And in this case, since the body is not moving, no frictional force will be developed.
So what is the stress induced?
Stress is like 5 Newton upon the area, area and area.
Can you draw Mohr circle for this?
Mohr circle, it is a 1D, like only 1D state of stress. Since it is compressive, it will be one point is on the negative x-axis, and the sigma x is 0, and 1 point is this. And the Mohr circle for this case is a circle with one of its diametrically and at origin, and one at the stress value, say 5 upon the area value, and it will be on the second and third quadrants.
Can you show me the diagram? Okay, good. Tell me what is the maximum shear stress?
Sir, maximum shear stress will be the radius of the mode circle, it is half of the normal stress, normal compressive stress will form.
Acha, you were Pavan talking about the material of the pipes.
Yes, yes.
What was that?
Sir, it's a X70 grade steel PSL2. Yes,
What
sir, X70.
percentage? Carbon?
0.12% carbon, sir, with many other alloying elements like molybdenum, vanadium, copper, many others are also there.
So do you know something about heat treatment?
Yes, yes, sir.
So suppose I heat treat this material, what is going to happen?
Sir, heat treatment means that depends. Like if we are doing annealing, then its strength may improve. If we do normalizing, then its strength will improve. Like that, sir.
So
Internal
if I want to
stresses may
increase
be
the
relieved.
hardness, suppose I want to do increase the hardness, how shall I do that?
Okay. Sir, quenching, we can do quenching, like heating to above the recrystallization temperature and then cooling it in a like oil bath or salt bath. So that a rapid cooling takes place. With that high rate of cooling, the grain size will be smaller. Grains don't have sufficient time to grow bigger. Because of that fine grains, we can get hardness, sir.
Okay, a pipe, oil pipe in the summers,
Oil pipe in the summers.
its
Okay.
temperature is increasing, it is going up to
Yes.
50 degrees centigrade.
Yes. Yes.
And then oil is flowing through that. Can I call
Yes.
it heat treatment process?
Uh, no, no, sir. Heat treatment means temperatures are somewhere around 700 degrees.
So what is the temperature range of tempering, annealing, and normalizing? What is the temperature range? Can you tell me that?
Sir, for annealing, we have to cool it. We have to heat it 40 or 50 degrees above the recrystallization temperature, which is 727 degrees. Sir, and these temperature ranges highly dependent on the types of steel also, whether it is hypoeutectoid steel or hypereutectoid
So we are
steels.
talking about the steel you mentioned, 0.12. What is that range?
Yes,
0.12 percentage of carbon.
0.1 to hypoeutectoid steel it will come under. Uh, for that, annealing range will be somewhere around 727 degrees centigrade, and normalizing I think.
And what is the range of tempering?
Sir, tempering, I don't know exact value, but it's less than the recrystallization temperature.
How less? I mean, can I say 50 degrees centigrade is tempering?
No, not 50 degrees, sir. Below the 50 to 70 degrees below the recrystallization temperature.
Are you
All
sure
these,
about that?
sir, for temperature range, I am not very sure, but they are
What is the purpose of
around it.
tempering? What is the purpose of tempering?
Uh, Sir, to increase the toughness, sir.
Sure.
Yes, sir.
What is the English meaning of tempering?
Temper,
Tempering.
angry,
No, that is not
angry.
temper. That is temperament.
Yeah.
Tempering. No idea?
No idea.
Achha, do we do heat treatment of cast iron also?
Um, Cast iron. I haven't heard that, sir.
Do we cast steels also? Casting process?
Sir, casting, for cast iron, the castability is good, sir. For steels,
So answer my
generally,
question. We do not cast steels normally. We do not heat treat cast iron. Why?
yes, sir.
What is the reason?
Sir, that depends on carbon percentage. With increase in carbon percentage, the castability will increase, sir. And sir, for cast
With
iron,
increase in cast iron, with increase in percentage of carbon, so
strength will
cast
also
stability
increase.
increases. Is that what you're saying?
Yes, sir.
Why?
Sir, reason exactly not sure, sir.
Okay. So Pawan, let me give you the feedback of your mock interview. How was it? How many marks will you give out of 10 to yourself, to a scientist of ISRO?
Maybe 6,
And how much is required to become scientist?
at least 8.
Yes, that is my marks also. So why you think
Okay.
6 only? Pawan?
Maybe these tempering ranges I am not able to answer, and for GSLV and PSLV information I am not able to answer
Actually, just
correctly.
go through the document which I provided you for ISRO. Go through that document.
Yes, sir.
And
Okay.
in that document, very clearly it is mentioned about what is polar satellite launch vehicles, what is PSLV, what is GSLV. They are the launch vehicles, platform
Yes, sir.
from where
Nice.
satellites is launched. So they are different in their ignition stages. Like PSLV, first SLV came, then ASLV augmented came, then polar came, then geosynchronous came, right? So roughly,
Yes.
geosynchronous GSLV is used to launch heavier satellites. Now India launches, ISRO launches satellites in two main categories: remote sensing, they are called IRS series, and then communication satellite, they're called INSAT series. So that entire information is provided in the document which I've given you. Now they're called polar because they move from pole to pole, north pole to south pole. They move very fast because they are 800-900 kilometers above the surface of earth, and they're used for their eyes in the sky. They are eyes
Okay.
of particular country in the sky. They are used to see the remote sensing, remotely to see the things, right? Like forest coverage area, flood area, something like that on the earth they want to see. Communication satellite are geostationary. That means whenever we see on the head of us, communication satellite will look like stationary. Remote sensing
Okay.
will look like moving. So they move from pole to pole. Geosynchronous is on the equator, very close to equator. So three satellites can cover entire globe. So if I'm calling somebody in US, so my signal will go to communication satellite, then that will be sent to another communication satellite. So that is how 120 degree ke upar I am going to cover 360 degree, right? So US is
Yes.
180 degree opposite to India, right? So that is how communication satellite is used. So that entire information is there in the document. Please go through that.
Okay.
So name of the scientist very nicely could explain Vikram Sarabhai, Satish Dhawan, because the name of ISRO basically ranges and centers are on there. Vikram Sarabhai Space Center, Satish Dhawan High Altitude Ranges, something like that. Abdul Kalam. So there, that rightly you explained. But then when I entered inside the topics, modeling analysis, Reynolds number, fully submerged flow means on one side of that there will be one liquid only. Like oil, the pipe, inside the pipe it is fully developed flow. So pipe,
Yes.
one side of the pipe is fully submerged in the oil, other side is fully submerged in air, and on this side there's totally oil. So it is fully submerged flow. Reynolds number can be used for its modeling, right?
And what other numbers, sir?
So there is a Froude's number is used for your partially submerged
Uh,
flow, open channel flows.
yes, open chat. No, no. For this case only, I am asking. For
Only
this case,
Renault
what
number.
are?
Only Renault
Yeah,
number
yeah,
can be used for its
yeah,
modeling. That is pipe modeling के लिए we use Renault number, right? Because
yeah.
it's a fully
That's what.
submerged flow.
So my
So
answer is correct, sir.
you were confused between fully submerged flow. You say no, it is not fully
Uh-huh.
submerged flow. It is a
Yeah,
fully
yeah.
submerged flow. That is what I'm explaining you. And then second law, I took you to the physics. Second law. So first part is net force is what force I applied and friction. So it is a static friction, which is a basically self-adjusting friction till limiting friction. After limiting friction, there is a maximum friction. There is a sudden fall in limiting friction. when it starts moving, because bonds are broken. So cold junction bonds are broken in sudden fall in the friction. So coefficient of static friction and coefficient of kinetic friction are different. Coefficient of kinetic friction is less than coefficient of static friction. That is the reason I asked you what will be the kinetic friction. 10 Newton? You will say no sir, less than 10 Newton. Why? Because coefficient of kinetic friction is less than coefficient of static friction. And this friction is less because the moment body starts moving, the bonds are broken. And friction reduces. That is the answer I was expecting. And then when you apply force on the vertically, yes, the stress answer was correct. Mohr circle was answer was correct. Shear stress, that was also correct. And then I took you to material science, you know, that you mentioned about 0.12 percentage. Yes, tempering can be from very low temperature to below the that particular critical line. Recrystallization temperature, that is a tempering, all the ranges. Tempering is to make it mild, you know. When you do quenching something in normalizing, then the hardness is very high because of grain structures, and I want to basically make it mild. I don't want it to be very hard. So tempering is done to make the things mild. Tempering is making it mild.
That means indirectly like increasing toughness only, no?
No, toughness is something which you need to increase the size of the grains. Reduce the effect of hardness is main purpose of tempering. You must have heard about martensite. Have you not heard terms like Mar tempering, Os tempering? Have you not heard?
Yes, sir.
Martensite is a result of normalizing process. When you quench it, and then it becomes very hard structure. Now I don't want that hard structure. I temper it. Tempering is making it mild. To increase the toughness, you know what I will do is I will increase the size of grain by controlled cooling. Like annealing and all I will do for that. So ductility I want to increase, toughness I need to increase. That is what I will do. So that concept should be good with you. So this is how it is. So now let me tell you, the interview in ISRO is thought provoking. He will drag you in one particular direction and try to see your approach, not answer, approach, how you are answering the things. I will drag you in physics, and I am recruiting scientists, you know. I'm not recruiting you for public sector. It is not a one liner rapid fire interview. Maybe I'll ask you only 2 questions for 30 minutes. And what is in PSU? I'll ask you 10 questions in 5 minutes. So listen again difference. In ISRO, in DRDO, in BARC, I'm going to ask you 2 questions for 30 minutes, 45 minutes, 1 hour. I'll take you in deep inside the concept. I'm recruiting you for your divergent thinking, your thinking approach, not for your knowledge. In public sector, I'm recruiting you on the basis of your knowledge. I'm sitting with a question, I'm giving you rapid fire. Okay, tell me what is the percentage of carbon in mild steel. Okay, tell me at what percentage you get eutectoid steel. Okay, tell me what is martensite. If you answer okay, if you don't answer, I go to next question. But what is in ISRO? If you don't answer, I'm going to give you clue. Okay, Pawan, tell me this. Pawan, do you think this way? Why? What is the reason of friction? Okay, this force gives you acceleration or this force gives you stress. That is what the ISRO approach is. Start thinking like scientist.
Yes.
Got my point?
Sir, this inertia force, is that correct, sir? Inertia force is 0 since it is not
moving. Yes, in the first case also, second. What is inertia force? If body is not moving, there is no inertia, you know. Inertia of rest,
inertia force, what is
if the body moves, simply, if the body, see, external force, no? Yeah, MA only. Okay. MA only, very true. So that is MA. But what is MA? What is acceleration in first case? 0. What is acceleration in second case? 0. So there is no change in inertia. Inertia is resistance to change. Inertia of rest, inertia of motion, and inertia of direction. There are 3 inertias. So first case, no inertia. First case, no stress. Second case, no inertia. Second case, stress. And if it is stress, draw Mohr circle. And what kind of stress? Compressive stress. Okay. What is principal stress? Compressive stress. And what is shear stress? Radius of Mohr circle. That is how you need to link the things. Yes. Okay, Pawan. So I give you 6 out of 10. And dear, if you want to become scientist, you need to have 8 out of 10.
Yes. Sir, and sir, this cast iron castability.
Yes. Now, cast iron, as the name shows, it is good to cast. It is flowability is good. There is a term called flowability. It flows. The difference between cast iron and steel is In cast iron, percentage of carbon is more than 2%.
Yes.
So if the percentage of carbon is more, the other alloying elements are less. There is no scope for other alloying elements to be added in cast iron.
Yes.
And in the steel, there are alloying elements. Now,
Yes.
in the steel, cast iron percentage of carbon is less, so I can add, other alloying elements. Iron carbon diagram, interstitial defects. Now, suppose in the steel, there are more alloying elements. They obstruct the flow. Steel cannot flow in the molten state easily. And if it cannot flow easily, flowability will be less. Casting will be difficult.
Yes. Sir, and regarding heat treatment, sir, there was a one thing I studied, that minimum heat treatable steels. Like if it is below 0.3% carbon, we can't do heat treatment. I studied it, sir.
No, you need to tell me exactly, because 0.8% is the typical steel. Eutectoid point.
Yes,
Perlite,
yes, sir.
it is called perlite. That is the best. Because
Yes,
of
sir. I am saying
because of different.
if it is carbon percentage less than 0.3, we don't do heat treatment. We can't do heat
Because
treatment.
it
Is that
becomes
true, sir?
pure iron. No, it becomes towards a pure iron. So as
Sir,
it
in that
becomes
case,
pure iron, yeah.
okay, in that case, if I see the carbon percentage for the pipe material is 0.12, so we don't do heat treatment.
No, we do. There are some. I did not ask you normalizing and annealing. I asked you tempering. I was asking you that question. What is tempering? If in the sun, if it in the hot summer, I put that pipe, is it a tempering? That is what my question was.
Sir, it was, is it tempering, sir? I think
No,
it was
it is
not.
not tempering, because the temperature rises in the sun slowly.
If it is like direct cooling, direct heating of 50
Tempering,
degrees, then
before
sir,
tempering, you should have basically quenching or normalizing. Then only tempering helps.
yes, yes.
So that concept should be clear, Pawan.
Okay.
Done?
Mm,
Prepare well, and approach
yes, sir.
is very important.
Yes, sir.
Okay, Pawan, have a nice day.
Thank you, sir.